So just to kind of catch us up a little bit, in the first two videos we discussed the relationship between f prime and what that could tell us about f, and also what f double prime could tell us about f. And we looked at all the symbols and all the different ways to say it and think about it and interpret it. And now I want us to look at some graphs and just take a look at what a number line analysis for both the first and second derivative would mean to us about the graph. So because this is new to us and we've never done this, we're just kind of doing a real easy little thing to begin with, and then later on we might have to look at it a little differently, but that's okay. We can adjust, right? Okay, so here we go, and let me move my little, there we go. All right, so let me get my pen ready. So what we're going to do is we're going to look at these graphs, and for the first derivative, so we have the first derivative in pink and the second derivative is in green. And so we're going to look at this graph. This is f. This is actually f. And we're going to look at places where the slope is 0 because f prime is the collection of all the slopes. And I see a slope of 0 at A. So I'm going to put A right there. And I'm going to put a 0 above it. And that tells me that's the value of it. Okay? And I'm going to do that kind of smaller. Let me make it a little smaller. There we go. And then on either side of that 0 might be a change in sign. So we talked about yesterday that when f, this is f, and let me write that again, this is f. When f is increasing, f prime is positive. And when f is decreasing, f prime is negative. Okay? And so sometimes after we do this, we'll write what that means about f at the top. And so that means increasing and decreasing. And because it increased to decrease, and there was a 0 right there, that actually is that point that we talked about yesterday called the relative max. So notice that on the first derivative number line analysis, that's what NLA means, number line analysis. We write the value of f prime, and then we kind of do a translation to what that means about f at the top. Okay? For f double prime, what we're going to do is look and see if there's any concavity change, because that's a point of interest to us. And I see that this entire graph is concave down for the entire, like a frown, for the entire graph. And so f double prime will be negative everywhere. There is not a place where there's a change at all in inflection, so we don't even have anybody to put on this number line. So when you see a number line like this for the second derivative, that means that f is concave down everywhere. Okay? So you put the value of this derivative and then what it means about the original, and the value of the second derivative and what it means about the original. Okay? So let's look at this second example. Oh, it looks like somebody just flipped this guy upside down. So at B, I still have another questionable point. It is the point where the slope of the tangent line would be 0. And on the left of that, I have a decreasing function, which means the first derivative is negative. And I have an increasing function on the right, which means decreasing, increasing, right? So I'm writing the signs of the first derivative and telling me what that means about the original on top of it. That helps me kind of denote that. And then if you decrease to increase, there's a relative, not a max, but a relative min at that. See that little bottom of it? They're really supposed to join smoothly, and that's a kind of a goofy graph. And if you'll notice, this graph does not change concavity everywhere. It is concave up like a cup. Ha ha ha. So it would be positive. The second derivative would be positive everywhere, indicating that the original graph would be concave up. So notice I'm putting the sign of the first and second derivative in the number line analysis, and then I'm going back and telling me what that means about the original. Okay? This will be a little different than some other things that we do, but remember, this is an introduction to how you look at number line analysis and how it goes with the graph given. In the third example, notice that there's a horizontal tangent at C, so that's a point that we want to look at has a zero slope, and this is decreasing, so f prime would be negative, and this is decreasing. So if you have a 0 point and it remains decreasing throughout that point, that means you have what we call a horizontal layout, where the graph kind of lays out horizontally for just a minute, goes down, like a cubic does, and this is actually like a negative x cubed because it's going backwards, right? And so it's, when I think about this and I see this setup of the first derivative, and I go, decreasing, 0, decreasing. Well, if you had to do that, you had to stop and be flat for just a minute and then continue to go on. So that means that that's that horizontal layout right there, just a little small layout where it kind of goes horizontally and then continues to go on. So this is what the number analysis looks like. It goes negative, 0, negative if there's a horizontal layout. And then if it goes negative, 0, positive, it's a relative min. And if it goes positive, 0, negative, that means it's increasing or decreasing, which means that's a max. Okay? So again, here's this, oh, sorry, I got to do second derivative. Sorry, I got excited. So is there a change of concavity here? In this graph, it looks concave up for that piece, and in this, the second part of the graph, it looks like it's concave down. So we're going to put C down as a questionable point on the second derivative. And it will probably be a 0, because it will be defined, and it will be concave up. That means the second derivative is positive, and I'm going to write that. That's what that means. So if the second derivative is positive, the original is concave up. So I'm kind of writing the sign and then what it means about the original above. And then this is concave down, so that means the second derivative is negative. Then I'm going to write what that means about the original. If it does change concavity around the 0 point, that is a point of inflection or an inflection point, however you want to say that. So that's a point of inflection or an inflection point right there at C. All right, so in D, kind of the same thing, except it's kind of just turned around. So that's increasing, 0, increasing. So increasing means the first derivative is positive. It goes to 0, which means it has that horizontal layout, and then it increases again. So if you see a first derivative number line analysis that looks like that, that's what the graph looks like. That's how you interpret that. And again, we're going to have that 0, and that's concave down, so it's negative for the sign of f prime, and it's positive, concave up. So now I'm going to write what that means about the original. So the value of the second derivative tells you the concavity of the original. So this is the sign, the positive or negative. This is what it means about the original. So I can kind of interpret that. Okay? All right. Let's go on to the next little problems. And this is still on page 88, just right below it. So now I look at this graph and I go, whoa, Nellie, what's going on here? Because right here, the tangent line here would be like a vertical tangent line, which means it would have an undefined slope. So when you look for places of interest that might be put on your number line analysis, it's usually going to be a place where the derivative is 0 or undefined, and those are called critical points. A critical point, this is kind of critical, haha. A critical point is where f prime is either 0 or undefined. So that's who you put on your number line analysis. That's who your little breakpoints are. So E is sitting right there, and this is increasing, which means the first derivative is positive, and then decreasing. Oh, I wrote decreasing instead of negative. Crazy me. There you go. So now I'm going to write about the original. It's increasing and decreasing. So if it increases to decreases, that means that this is a relative max. And this actually is an undefined derivative. Okay? Sometimes when you see number line analyses in books, they'll have an infinity symbol here. It doesn't matter. You just need to say, I just need to know something about that. And if it is an infinity symbol, that probably means you have this, we call this a cusp. And so you have this cusp going on right here. And this is a place of interest because if it's undefined here, it's going to be undefined here. So that means we have a possible inflection point at E. So let's talk about the concavity. I'm concave up, which means the second derivative will be positive. I'm also concave up because it would hold water. So even though this is undefined, because if it's undefined in the first derivative, it will be in the second as well. We're concave up. We still have no change of concavity. E is not a point of inflection. E is not a point of inflection. Okay? So if there is no change, see the sign changed, the sign did not change around E, so E is not a point of inflection. Okay? Really important. In order to be a point of inflection, you can be a suspect if your second derivative is 0 or undefined, but you can't actually be a point of inflection unless the signs change around that or your concavity changes on your original graph. Well, let's look at this crazy little guy. I'm curious about F. I don't know what's going on, and I do know that that's a corner, right? A cusp, a corner. Those are bad places to have derivatives, and it is undefined there. And so it's also going to be undefined in the second one. I can go ahead and put that there at this letter F. And let's look at this. This is going down. Slopes are decreasing, right? So it's negative first derivative, and then it's going up, positive. Slopes are positive. That means the original graph is decreasing to increasing. And because you're decreasing to increasing, this is a relative minimum on the original. So the signs and how they change around a 0 or undefined point tell us things about the original. And there is no concavity here, none, because there's no curve to this. So if you can't hold water or water won't run off of you, well, you can kind of hold water at the V, but it needs to be curvy in order to have concavity. So this does not have any concavity. There's none at all for that second one. All right, let's look at this. Cusp, corner, this is go vertical. It's going vertical right there at G. So that's going to be a place of interest on both the first and second derivative because that is where the first derivative is undefined, like and, crazy. And then this one is undefined as well. All right? First derivative is always increasing and decreasing. This is increasing and increasing. So that means that the first derivative will be positive around that. So if you increase throughout an undefined place, that means that you go vertical. So that's what the number line analysis looks like when you go vertical, because you continue to increase through an undefined derivative. And, and so you don't have a relative extrema. So you have relative maxes and mins here. You don't have a relative extrema right there because it continues to increase throughout that undefined place. In this case, this is concave up. That means the second derivative will be positive. This is concave down, which means it will be negative. And I'm going to write that up there. Did it change concavity around an undefined or 0 place? Yes, it did. So G is a point of inflection because the second derivative is 0 or undefined, and it changes signs around it. So G is. And H is just like G turned around, pretty much. I'm trying to put the letter. It's not really in the middle, but and that's concave down. Oh, sorry. Hello, decreasing throughout. Let's do first derivative. First derivative is increasing and decreasing, right? Come on, crazy lady. So it's negative throughout, and there's an undefined slope. So you're decreasing throughout this undefined place. And now let's talk about concavity because it's the second derivative. Concave down means the second derivative is negative. Concave up means the second derivative is positive. So that's concave down to concave up around an undefined second derivative. So H is a point of inflection. Okay? So we will be using these number lines, and we'll be using them in a different way where you're not given F, you're given something different. But I do want you to know that if you're in these different situations, then you know kind of what's going on in the graph. So just some things to remember. If you increase to decrease around a 0, you have a relative max. If you decrease to increase around a 0, you have a relative min. If you continue to decrease or increase throughout and have a 0 or an undefined, you do not have a relative extrema, right? If you increase to decrease around an undefined, you have a relative max. And if you decrease to increase around an undefined, you have a relative min. So you've got to change the sign around your undefined or 0 to have a relative extrema. A little bit about the second derivative. Sometimes you don't have a point of inflection because it's concave up or down the entire time, right? In this case, we did have a point of inflection, and in this case, we had a point of inflection right there at D. And I'm going to go back and rewrite this. So this is a point of inflection right here. Why is it a point of inflection? Because the second derivative was 0 or undefined, and the concavity changed. The sign around that place changed on both of those. Let's go back to this one. There's a 0 and the sign changed, which means the concavity changed, and so it is a point of inflection. And the kicker is, if you have an undefined place and the concavity does not change, then it is not a point of inflection. In order to have a point of inflection, you have to have concavity. If you don't have any concavity, you can't have a point of inflection. So that is the introduction to how number line analysis can show you what's going on in the graph. Hope this has been helpful. Thank you, and come back for the 4th edition of F, F prime, F double prime.